Hello and welcome to the presentation and final portion of this training series. In this video, I'll show you a few different ways you could present your work by using snapshots and CLO's internal render engine. Before I begin presenting our garment, there's a couple of steps I usually like to take to ensure my garment looks its best for presentation. The first thing I do is change the avatar's pose to the attention stance, so that the garment's fit is more relaxed on the body. Next, I'll apply the high-res garment function, which is up here within the 3D toolbar. That optimizes my garment's quality. When selecting that, you'll get the high-res properties window. What this does is change all the patterns to a particle distance value of 5. It also lowers the additional thickness collision value between patterns. This pertains to the invisible buffer or collision mesh between pattern pieces to ensure more stable simulation while working. By lowering this value, it will cause the pattern pieces to drape closer to one another. The avatar's skin offset is pretty much the avatar version of additional thickness collision. By reducing this value, it'll cause the garment to drape directly on top of the avatar, which ends up expressing more realistic draping. And lastly, the simulation quality is changed from normal to complete, which is the most thorough form of simulation to calculate the fabric's physical properties. To apply those changes, I'll select OK, and wait for it to kick in. And you'll notice that the simulation arrow now changed to a double red arrow. When you apply it, refrain from clicking around the program while it's simulating. Gradually, you'll see more detail come through as it loads. Once there aren't any noticeable changes to the drape of the garment, I'll turn it off. And once you're ready to present, there's a couple of ways to present your work. One of the quickest ways is using Snapshot. You can find it by clicking File, Snapshot, 3D window. I'll have to give it a name. And then the snapshot window will appear. For those of you who watched the previous colorway tutorial, this is the same snapshot feature. Here you could start by saving a single image, customizing the image size, as well as the option to set a transparent background, and save the image in all colorways if you've already built those out. There's also a multi-view option that allows you to save out multiple views. You can either use the preset views or take your own by positioning your garment within the 3D window and clicking on this camera icon. Again, you could customize the image size, specify the view count, which is a max of 8 images, and the view layout that varies from horizontal, vertical, or box horizontal and vertical. Also, again, the option to save views with transparency. You could save each image as an individual image, and lastly, save out all colorways. So if I go ahead and save this out, and return to that browsing window where I saved them, you could see that it includes one image with all my views combined in a single image, as well as those individual views separately. Another way to present is by creating a turntable video. You could find that in File, right below Snapshot is Video Capture, Turntable. This turntable video capture window will appear and allows you to customize the video size, the direction the garment rotates, and the duration of the video. Over here you could specify which video codec to save out as. If you haven't already downloaded these, CLO will link you to the proper installers. When you're ready to record, click the record button and give it a second to process. Once it's finished, you could preview the video by looping it and pressing the play button. When you're ready to save it out, click Save, give it a name, and then save it out as an AVI video format file. If you're going for a more polished presentation, you can utilize the internal render engine. You can access the render engine by selecting Render up here, or right-clicking in either the Object Browser or Property Editor window. The render window will appear and instruct you to click within the window to start the interactive preview. And here I'll get a preview of the rendered image. You can either navigate in the 3D window, or by using the same controls, do it within the render window. These first three icons are the stop render, play, and refresh buttons. Sometimes you'll need to stop your interactive render and refresh to make updates. For example, if I decided I wanted to hide my avatar, you'll see that it doesn't update in my render preview. So what I would need to do is stop my render preview and then hit refresh to apply those changes. So I'm going to actually keep my avatar. If you're ready to render, you have to first stop the preview in order to select Play Render. We'll save that for later after we go through the rest of the tools in this toolbar. Here we have Copy Current Image, which essentially takes a screenshot of our current render preview and allows you to paste that image in other external programs. Next to that is Save Current Image. This gives you the option to save out that screenshot of the preview. And beside that, you have Show in Saved Folder, where you could locate where your image is saved. So here's my image. This isn't necessarily a complete rendered image, but is a helpful alternative to quickly save out render previews. The difference between this and a snapshot is that this image considers your environmental lighting and expresses certain material types that can only be visible in the render engine. I like to think of these options as an in-between of snapshots and fully rendered images. One of the main settings is the image and video properties. When you click that, the property editor will populate with the list of options. Any of these settings you customize can be saved and shared for other projects. The first option you have here is the format. You can render out images, turntable images, or animations. With turntable images, you could save out multiple views. For instance, if I wanted to save both the front and back view of this garment, I would select 2. 4 for the front, back, and side views, or even a full 360 video. You could save any image or turntable image in all colorways. Specify the rotation angle, direction, and save as video. And within the video options, you have total and frame duration. You can also render out complete animations. To do this, you would need to record an animation within animation mode, and from there you could specify to either render the entire region, as in the entire length of the recorded timeline, or a specific region, meaning a certain part of the animation. Then select Save Video and specify the frames per second. For this tutorial, I'll keep it as an image. Below image is viewpoint, which by default is set to current view. However I have my garment positioned in the 3D window is what the final output will be. There's also an option to use custom views. By selecting that, the custom view window will pop up, or you could right-click in the 3D window and select custom view. Much like snapshots, you could position your view within the 3D window and create your own custom views by clicking on the camera icon, and also rename them. I'm going to reposition my view and take one more additional custom view. Once you take your photos, you could toggle between the views and keep your positioning consistent while working. So I have 2 for example, and when I select custom views, I would get a total of 2 rendered images. And again, the option to render all colorways for images. Below that is the image size options. The default size is set to pixels, but if you select any of these other presets, you'll get the option to select which units to use. For mine, I'll pick inches and maybe do 6 by 6. Also here, you could control the pixels per inch to improve the image resolution. Next, you have background. The same as changing color and anything else in CLO, click on the swatch to use the color window. And select a color to use as your background. While choosing background colors can be fun, I'd like to note that it may increase your render time, because it's that many more pixels to process. As opposed to setting it with transparency, only the object is being rendered. And on the bottom here is the file name. So you can either save out as the current project name or create a custom name. The file path where the render saves to, and then your image format is either a PNG or JPEG. In order to maintain transparency, you'll have to export it as a PNG. So our next setting is the lighting properties, which is the little light bulb icon here. And that consists of the dome light, which is the environmental lighting within the 3D scene. So if I toggle this off, it's the equivalent of turning off the lights in the scene. The lighting is created by environment maps, which are HDR file types. CLO provides several default environment maps that vary in brightness and contrast. Some of the commonly used ones may vary from high, medium, to low contrast, but it really depends on how you want to present your garment. For example, I'll choose high contrast, which you can see immediately casts different shadows and changes the overall mood. The light intensity controls how bright the environment is. For the most part, I'll keep it at the default value, but you may need to increase the brightness for garments that use darker colored fabrics, as you may lose some details if it's not bright enough. Light angle controls the direction of the light source. By moving the slider, the light source changes. The idea is you want to adjust the light angle to illuminate the garment in the most appealing or realistic way, and try to prevent it from casting any harsh or unflattering shadows. This lock to camera feature helps keep the light angle consistent if you're rendering multiple views. So rather than the avatar, for instance, rotating in the 3D scene, which ends up casting different shadows on different views, instead the actual set environment lighting rotates with it. You can also choose to show the HDR image. In addition to light, HDR files also have complementary panoramic images. Besides the CLO default environment maps, there's plenty of resources online that provide HDR files. To apply my own, I'll navigate to the browsing window and apply some I downloaded online. I'll just need to select it and hit open to apply. So this particular HDR is indoor lighting, and looking at my preview, it seems that the light source is behind my avatar. So I'll have to adjust my light angle until I light up the garment to my liking. Now when I select Show, I'll see the HDR file's background image. But make sure that that lock camera setting isn't applied in order to move around your 3D scene. Now as I rotate around the 3D space, you can frame the different parts of the background image. To make the scene a bit more realistic, you'll probably need to adjust the perspective so that the avatar is to scale with the environment. I have another one that's an outdoor environment. What's great about these environment maps is not only can you style your renders, but also view your garments in natural versus commercial indoor lighting. In addition to the environment map, there's also several rectangular lights that you can apply to further control the lighting in your scene. Click on the boxes to activate them. You'll see that their default position imitates a traditional studio lighting setup. There's the two on the sides and one overhead light. They each have their own set of properties, and if you select one of them, you'll only see that particular light's properties. I could change the intensity, which is the brightness of the light. Once I adjust that to a higher value, you could see those changes in the preview. You can also change the color of the light. So if I select one, you could see the hue is now reflected on the garment. And then the width and the height pertain to the size of the light. The larger the light is, the more light it will project. If you're using these lights and they appear in your preview, you can uncheck Show to hide them from your view, but they'll still project light. You can also reposition them by simply clicking and dragging them or click once on them to activate the gizmo. I'm going to toggle the additional lighting off and stick with my environment map. Okay, so next to lighting you have the camera properties. When I click on that, you'll see the settings in the property editor. Starting with the lens field of view, which sets your view range. So I've been using the default front view shortcut, which is the current value at 15. If I change this to a higher value, it will increase my distance away from the avatar. Now all my shortcuts will change to that field of view, whereas a lower value will be closer in distance. So I'll just keep that at 15. Right below that is view orientation. There's two types to select from. One is spherical, which adjusts and rotates the view with the object centered. There's distance, which will zoom in and out. Horizontal angle will spin around the avatar. And vertical will rotate around that avatar. The other is absolute view, which centers from the X and Y axis. Adjusting horizontal will slide along the X axis of the 3D scene, along with vertical on the Y axis. There's also the option of activating physical camera effects. Click on this box to see the different options. There's exposure, depth of field, and effects. If I toggle exposure, I can adjust the brightness of the scene without adjusting the lighting itself. In order to see these effects, be sure to stop and refresh your render preview. So within exposure is the ISO value. This in traditional photography pertains to the camera's film sensitivity. The smaller the value you apply, the darker the image will be, while larger values will brighten up the image. To test that out, if I reduce it to 200, the image becomes noticeably darker. Below that is the f number, which is the camera's aperture. This refers to the lens opening size, through which light travels. The smaller the value, the more its aperture is opened, resulting in a brighter image. So that lens ends up taking in more light. By reducing this value, it'll significantly brighten the image. The shutter speed is the length of time in which a camera is exposed to light. If the shutter blinks a lot, the camera lens doesn't receive as much light, resulting in a darker image. Higher that value will also dim the image. And the white balance over here defines which colors should actually be white and helps improve the colorization within the 3D scene. So a lot of times in photography, the surrounding environment can affect the hue of the subject. This helps retain the color balance of light and is used to prevent any tints from the environment's lighting. Below that, you have depth of field. If you toggle that on, there's a focal distance and focus by left click. If I select focus by left click, let's see, if I zoom in here, I'm going to go for a close-up shot with her shoulder at a closer perspective. When I click on her shoulder, the focus distance will adjust to focus in the area I select. You can also use the f number to help blur anything outside that focal point. Once I let the preview settle, you'll see that the shoulder is in focus, whereas the edges and everything outside the focal point are now blurred. I'll revert back to the default settings. And then lastly on the bottom here are effects. These effects distort the image. To apply the effects, just input a smaller value that's less than 1. This will stretch your image either vertically or horizontally. I'm also going to toggle off the exposure here. And lastly, the final setting is the render properties. Starting with the render engine, which allows you to specify which device your computer uses to render. You have the options of CPU, GPU CUDA, or GPU OpenCL. So if you use the CPU, you can only use that while rendering, versus GPU CUDA, which gives you an additional option to have the CPU supporting. This will increase the rendering speed. The GPU CUDA is also the optimal setting if your computer is using a NVIDIA graphics card. There's also GPU OpenCL, which can be applied for PCs with either the AMD Radeon or Intel graphics card. For the Mac users, you won't have this option. There's also low GPU priority, which prioritizes the GPU to process other functions outside of CLO before it's used in the render. In other words, CLO would be less prone to lag while other applications are being used. Next are the finish conditions. The noise threshold controls the clarity of the image. The lower the value, the sharper the image resolution will be, although keep in mind that lowering this value will significantly increase the render time to complete an image. Below that is max render time. On average, the rendering process only takes about 2 minutes when using the default settings for image and video properties, lighting, and render properties. However, the render time differs when the properties are modified. Some things that can contribute to longer render times include using large texture images, material properties such as fur, and/or any additional geometry in the 3D scene. Max render time will allow you to set the limit of time used for rendering each image. Just note that if you set a shorter image, that image's clarity may not be at its best potential resolution. CLO will basically try to give you the best possible image quality within a given time frame. The quality settings improve the accuracy of indirect bounce light of the scene. This primarily concerns indoor scenes as bounce light is much more apparent versus an outdoor setting. For example, when textures are added to a studio environment such as walls and floors. Generally, the default medium option is sufficient when rendering a single garment, and the higher options don't really have a big influence on the render quality. There are special instances such as rendering light-colored fur that can benefit in quality, using the other options. Color mapping linear workflow refers to the calculation of light and the color from used textures, and helps ensure that the render output is accurate by using gamma correction. In most circumstances, you should leave this setting applied. And besides that, the last icon is the option to render via Closette. For those of you who aren't familiar with the Closette platform, I'd recommend watching our tutorial on how to navigate through Closette, which I will link in the description below. So if I'm ready to render this image, I need to stop the render preview and click on the final render icon. You'll see a progress bar pop up in the corner. I'll give it a few seconds to finish. Once the render is complete, an information window appears that will direct you to where the render image is saved. I'll select Open in Folder, and there you have it, the final rendered image. I hope you all enjoyed this tutorial and thank you so much for watching.